using powers. We're going to look at two different areas. We're going to look at geometry first, biology second. There's others. These are just the two that the textbook focus on, so I picked those to do examples. I'm calling the first one, I know it's crazy, but I'm calling it the cube example. I know. So when you go to do the homework and you see a cube, you're going to flip back and you're going to have one that's exactly like it. They're just going to change the numbers. Read to read. And a cup. Okay, let's read to highlight. What's important? Yep.
Cube.
Not just length, but edge length. What's another word for edge length? The side. Because it's a cube, what do you know about all the sides? They're equal, so all of these guys are the same. And it's 4. We need a formula for surface area of a cube. What's surface area of a square?
Side by side.
And how would we say side by side? Remember, this unit involves what now? Powers and exponents. So side times side we would write as side squared. And how many sides does a cube have? Try that one more time.
12. 8.
Let's just think for a second, yeah, rather than just randomly calling out numbers. It has a top and a bottom, a front and a back, a left and a right side.
8.
6 side squared is the surface area of a cube. That was a little painful. So this question is just a direct substitution. They're just asking you to throw in the side length, which is 4. This now becomes an order of operations question, which is what we did Friday. What do we do first? Brackets. Inside the brackets, can I simplify anything? Nope. So after b comes exponent. So I need to do 4 times 4. 16. Now the multiplication, 6 times 16. Again, in your head, break it up. If you can't do 6 times 16, break it into 10 and 6. What's 6 times 10?
106.
What's 10 times 6? 60. What's 6 times 6? 36. So how do you get 6 times 16 using those two numbers? Add them back together. 96. And then we need some units because it's a word problem. Centimeters squared. Why is it centimeters squared? Because it's a cube. Okay, so now when you see the cube question, now you're going to have one that looks exactly like it. They're just going to change the numbers. Look at number 2. What do you think? What crazy name am I going to call this one?
A circle.
We actually called it inscribed circle. What does it mean to inscribe something? It means to put it inside something. So this is actually a circle that's stuck inside a square. Okay, so we call it inscribed circle. Read to read. In your head, Yeb, in your head. Okay, read to understand. First sentence.
Circle.
Circle.
Square.
In a square. Yes.
20 centimeters.
20 centimeters.
Area. Shaded region.
So you've been doing these area of shaded regions questions since about grade 5. How do we find the area of the shaded? Well, we've got to find area of the square and then subtract off
20 centimeters.
area of the circle. So we need area of square minus area of circle. If you don't like my notation, don't use it. If you want words, use words. Formula for area of a square.
Length times side. Squared.
Side squared, we just did it above. Formula for area of a circle. You need to know this.
Diameter.
It's something with pi because it's a circle. Pi r squared. High five to you, Q. Pi r squared. Grade 7. So we know all four sides of the square are the same, and we know that it's 20. Okay, so that's not bad. I can put in the 20 here. What the heck am I going to do with the circle?
3.14.
So how am I going to get dimensions of the circle? Well, if it's 20 here and it's 20 at the top, what do you know about across the middle of the square? It's also going to be 20. So how much is the radius going to be? Radius is 10. Okay, brackets first. Can I do anything within the brackets? Nope, exponent comes second. 20 squared, you should not need a calculator. You can do 2 squared, which is 4. So 20 squared is going to be 400. 10 squared we would expect you to get without a calculator. 10 squared is. And I'm just going to stick it in front of the pi because we like coefficients to be at the beginning. At this point, it would be a calc question. So in your calculator, you're going to put 400 minus 100 times pi. Remember, on your scientific calculator, you have a pi button. So you're no longer typing in 3.14. You're past that. You're finding your pi button. There's a pi button. It's your big boy calculator. It just magically spits out of the calculator. Times pi. It might be a second function. It might be a button itself. It just depends on your calculator. 85.8407. Can you find your pi button? Those of you without your calculator, this is like coming to phys ed without your clothes. Sorry? It's like coming to math class naked. Exactly. Let's round to 1 decimal place. Do I have an answer? 80, but to 1 decimal place? 86 if we round to 1 decimal place?
I'll put 85.84.
Okay, so 85 point. If we go to 1 decimal place for the 4th time? 8? Does that sound confirmed? We would need some units. Centimeters squared. Now when you see this kind of diagram in the homework, you've got a question to flip back to. Let's go on to the biology examples. Read to read. Cam, foot off the desk, please. What's the question about? Bacteria is probably what you picked up the first time, and that's okay the first time through. Now we're going to read to understand, so let's pick this apart. What do we need in the first sentence? Double every hour. Really, in terms of the math, I don't care what's in the dish. The biologists care, but the mathematician doesn't. Second sentence. Currently 100. How many is a good word? Okay, so let's just stop and check that we have enough words highlighted. I want you either to close your eyes or look up and just listen, and I'll read the keywords that we highlighted, and you'll tell me if we have enough to solve it. So look up or close your eyes. Double every hour. Currently 100. How many? 5 hours in a day. Do you think we've highlighted all the keywords? Yeah, I think we're pretty good. Grab your red pens. This is the way all the biology ones are going to work.
The red ones. Cool. Slow it down. Yeah, give me one. Oh, well, if you're short, I'll be right back.
Take your time. Yeah, take your time. So the general formula starts with a P on the left-hand side, and P just stands for population. So that's going to answer our how many. So it could be bacteria, it could be groundhogs in the zoo, it could be anything that's multiplying. Equals the original amount times what we call the multiplier, which I'll explain in a second, the multiplier, to the exponent n, and n is time. Okay, so P equals the original amount times the multiplier to the exponent n, which is time. And I know that list's confusing. There's lots of words and stuff. You'll see with the first example, they're going to be the same every single time. So P is the population of bacteria. That's what we're trying to find it as. How many are there after a certain amount of time? What's the original amount of bacteria that we're starting with? 100. The multiplier refers to how often it's multiplying. Is it doubling? Is it tripling? Is it quadrupling? Is it halving? Is it quarter? What's happening to our bacteria? It's doubling. And what's the number that represents doubling? 2. So that's what we call the multiplier. It's how the population is changing. And n is going to stay a variable for now. Okay, so 100 is the original amount, 2 is the multiplier, and I'm going to substitute in a second. 5 hours, so for the first part, we're going to keep our 100, we're going to keep in 2. Question is asked for in 5 hours, so our exponent's going to be 5. Again, this is just a BEDMAS question, so nothing in the brackets. After brackets comes exponent. And again, what you don't want to do is this multiplication, and that looks like you should do it because it's left to right, but this is always exponent first. 2 to the 5 would be the highest we would ask without a calculator, so let's do it together. 2 times 2 times 2 times 2 times 2. Now the multiplication, 10 times 32. 3,200 or 3,200 units. 3,200 what? Bacteria. That's the answer for the first part. Again, at first I know the formula is like, whoa, there's all this stuff, but it's going to be the same every single time. Part B wants to know in a day. So P is still going to P, 100 still 100, the doubling is still 2, it's just n that's going to change. Instead of 5 hours, how many hours down the road are we looking? Well, how many hours in a day? 24. This would be a calculator question. Okay. On your calculator, you're still going to follow BEDMAS. You're going to do 2 to the 24. Then hit equal or answer, and then take your answer and times by 100. I'm guessing there's a lot of bacteria. Caret, hat, x to the y, y to the x, x to the n, x to the space. Anybody got an answer? 16, 7, 7, 216. That was the worst number I've ever heard read out. Are those the digits that you see? Okay, so now let's group them in groups of 3. So we can't have a 0, 0 on the end. So group in 3, it's going to be. So we're going to split there for 3. And here and here. So we have 1,677,721,600. Can someone confirm that very large amount of bacteria? And the units, bacteria. Ooh. What? You probably didn't times by 100 is my guess.
Oh.
Let's do another biology one. Oh, a good mosquito question. That's awesome for Winnipeg. We don't have snow, we have mosquitoes. Anybody else a little sad this morning when they looked outside? Oh, I knew it was too good to last. Read to read. What's it about? And that's all you probably got the first time through, and that's okay. Now let's read to understand. What are the key words? Starting population of 100. Quadruples each week. How many? In 4 weeks. 3 months. Do you see the similarity from this question to the last question? Okay, so let's set out that formula. It starts with P, which stands for population. Then comes the starting amount, which in this question is 100. Then we need the multiplier. It's not always going to be 2. It was 2 in the last question because it said double. Here it says quadruple, which means it's times 4, and then n. What does n stand for? The time. We can, but typically we use n because it's number of weeks, number of months, number of days. In 4 weeks, so 4 is going to go up here. Again, this would be a calculator question. So on your calc, you're going to do bedmash. You're going to do 4 to the 4. Don't forget times by 100. How many mosquitoes will we have? A lot. Offer? 25,600 is the offer. Confirm. Units. Bloodsuckers. Okay, so that was the first part. Second part's going to ask for 3 months. How do we convert months to weeks? How do we convert months to weeks? So can we assume that every one of those months had 4 weeks? Okay, so if every month has 4 weeks, and there's how many months in a year? 12. 12 times 4 is how many weeks? And is that how many weeks there are in a year? So we can't assume that every single one of them had 4. Okay, so what can we do to get exactly how many weeks were in 3 months? Number of weeks in a year, which is 52, divided by 12, and then we're going to times by 3. Offer? No offer yet? 13? So if you had just done 3 times 4, you would have had 12, but it's not, it's 13 weeks. Okay, so just beware, you can't just take number of months and times by 4, because we know that every month doesn't necessarily have 4 weeks. Sometimes there's more, sometimes there's less. Okay, if there's 25,000 mosquitoes in 4 weeks, how many are there going to be in 13 weeks? It's going to be a lot. That's our whole summer, by the way. Well, give me the digits, then we can break it into groups of 3. Okay, sorry, 710, 886, 400. So 6,710,886,400 confirm. That's crazy. Assuming we don't spray, which is why we spray.
Is it 400 exact?
That's what he said. 400 and? Oh, it is 400 exact. Part B, keywords. Hey, is your conversation done? I would do another word in there. So what is reaching 12,800? The population. What's the difference between Part A and Part B?
This one's division.
It might be division.
We put away the pens.
Perfect. This one gave us the time and was asking for population. This one is giving us a population and asking for time. So this time our value is going to go on the left. So now we're solving an equation. We're not just simply using our calculator. We've got to first get rid of this 100. What's the opposite of timesing something by 100? Dividing by 100. $12,800 divided by 100. Well, the zeros are going to go, so what's left? 128. Now what? Now what? Well, if we divide by 4, then we're going to have an exponent hanging around with no base. Can I have an exponent just dangling in the air? No, so all we need to find is 4 to the what gives us 128, so let's use our calculators. We know it's not 4 squared. How do we know using logic it's not a 2 in here? Because 4 squared is 16, okay? Is it 4 to the 3? Well, if you're not sure, you're 4 to the 3 and tell me what the value is. Okay, 4 to the 3 is 64, so we know it's not that. What's the next logical conclusion? 4 to the 4. 256. Offer a 4 to the 11. Okay, so 3 we said was too little, and 4 we said was too big. So what do we do if it's in between 3 and 4? 0.5, so try 3.5.
Yep.
Okay, and this just came from our calculator. Okay, so what we did is we tried 4 to the 3, which was 64. We tried 4 to the 4, which was 256. So if 64 is too low and 256 is too high, natural conclusion, in the middle. Last one, find a smart friend. I'll give you about 3 minutes to do it together. How many people set up the formula correctly? Okay, so 96 times 3 to the n. Okay. Question number 1, you're going to substitute in 5. Do I have an offer for the answer?
22,328.
Sorry, 22,000? 23,000. 28? Frogs? Is that confirmed? Frogs. Although it kind of looks like fogs, but or jogs. It's frogs. Second one, same thing except it's 50, and your calculator probably gave you a really weird answer, so tell me what your calculator said.
6.89. 182.
Oh, I got 7.
I got 7.17.
8, 9, 7, 9, 8, 7, 9, 1, 8, 5. E plus 23.
I got the second one. I have no clue. Why is there an E in there?
Well, I'm just waiting to explain, but you're talking and Alan's staring at his crotch, and that's really weird, so I'm just wondering what's going on here. It's kind of freaking me out a little bit. And other people are talking, having a conversation. So we need a confirmation because we have two different answers, so.
Second one.
Okay, well, first one, second one isn't confirming, so fight it out amongst yourselves.
By the way, the first one has a 2.
Okay, so everyone has to recalculate if you can't come to consensus.
Why is there a letter? And a plus.
Everybody has to recalculate when you can't come to consensus.
Is there an E? I got the first one. Show me where
I will explain the E after we come to consensus, but some people still aren't calculating it, so. Some people are just busy coloring in the frog. That's going to be helpful. Well, some people are trying.
Yeah, you got the same number.
Like Aaron.
I just did the 3, the happy roll over the numbers. Not the.
Oh, I got Kayla's number. Is this your number? I still got an E.
Wait, you did. It's not.
Thank you.
The carrot.
Hi, Claw.
Okay, so are we going with the first? Are we going with the second? What are we doing here?
Yeah.
So the first one hasn't times by 96. Okay.
The first one's times by 9. The second one is like the original 3 to the 50.
Okay, so give me the first one again then.
Oh, here, I got it.
Yep, waiting.
Oh, what?
35? 25? But it was nice and slow. I could get all the decimals. Can we confirm this and then I'll explain what the E is?
Yeah, I got that too.
We're confirming this. So what I'm going to do first is round to one decimal place. So we need to look at those three. And if we round to one decimal place, we get 6.9. This, you actually probably should have seen in science, but if you haven't, no big deal. The E means exponential notation, or sometimes it's called scientific notation. What the E means is times 10 to the 25. So that's 6.9 with 25 zeros after it. Is that a little number or a huge number? Huge number. So just note if your calculator gives you this, you write this. You don't write the E, you write times 10 to whatever the number is that follows. Units. Frogs. That's fine. Just depends on your calculator. You're going to open your book to the